Hello everyone. Continuing on, in this class we're going to do a couple more problems. Again, the basic idea is just generally to get people comfortable using the computer programs. We're in a situation where once you're able to translate from natural language into the proper problem formulation, there generally shouldn't be too many problems after that stage. So what we want to do, or what we did in the first half, was we really emphasized being able to properly translate from natural language into the proper universal problem format. Then we solved some manually, but we didn't stick to that for a very long time, only because we are in a situation where computers exist. And the computers are able to solve these problems for us if we properly format the problems. So that's kind of our focus right now, is learning to use the tools given to us to solve these problems accordingly. We don't necessarily have to manually solve them because we have the computers. However, to solve them properly, we do have to know how to use the computers well. That's kind of where we are now. So the first stage, and that's where we are now, is understanding what's happening and familiarizing ourselves with the capabilities of the two programs we're using, Microsoft Excel with the Solver add-in, and QM for Windows that's optimized for management science problem solving. So without further ado, let's begin. Today, the first thing we're going to do is look at the homework problem from the last session, or the class problem from the last session. This is the jewelry store example. It's in Chapter 2. It's question 11 on page 83. The jewelry store makes necklaces and bracelets from gold and platinum. The store has 18 ounces of gold and 20 ounces of platinum. Each necklace requires 3 ounces of gold and 2 ounces of platinum, whereas each bracelet requires 2 ounces of gold and 4 ounces of platinum. The demand for bracelets is no more than 4. A necklace earns $300 in profit and a bracelet $400. The store wants to determine the number of necklaces and bracelets to make in order to maximize profit. Formulate a linear programming model for this problem and solve it to determine the optimal manufacturing choices. So, first step, we have to formulate the problem. We know from the second last sentence, the store wants to determine the maximum number of necklaces and bracelets to make in order to maximize profit, that we are attempting to maximize profit Z. We know that a necklace earns $300 in profit and a bracelet earns $400. So our objective function becomes max Z equals 300x1 plus 400x2. Then we have to go to our constraints. The store has 18 ounces of gold in sentence number 2. Because it's limited, that is a constraint, and 20 ounces of platinum, a second constraint. Each necklace requires 3 ounces of gold and 2 ounces of platinum. So, we now know that 18 ounces of gold is our constraint. A necklace is 3 ounces, so 3x1, 3 per bracelet, plus 2x2, 2 ounces of gold per bracelet, must be less than or equal to 18 as our first constraint. 3x1 plus 2x2 is less than or equal to 18. Our second constraint, 2x1 plus 4x2 is less than or equal to 20, which is the platinum for a necklace, the platinum for a bracelet, and the total amount of platinum. Finally, the demand for bracelets is no more than 4, so x2 must be less than or equal to 4. We move on and we see that here. Excuse the writing, I'm having trouble with my camera. Maximum Z equals 300x1 plus 400x2, subject to 3 constraints. 3x1 plus 2x2 is less than or equal to 18. 2x1 plus 4x2 is less than or equal to 20, and x2 is less than or equal to 4. All three of these constraints, when taken together, will allow us to determine our optimum choices. Let's look at that now. To do that, we go to QM. As always, we click on Module and down to Linear Programming, because as I said, for right now, we're still focused on linear programming. And we open a new spreadsheet. We'll call it the jewelry store problem. And then we enter our constraints and variables. We are still, and will be for a little bit, still on 2 variable problems. So this doesn't change here. But we have 3 constraints in this situation. So we change it to 3, and it's a maximization. Again, this doesn't matter. We click OK. Our first possibility is necklaces. Our second, bracelets. We're trying to maximize if necklaces give us $300 and bracelets give us $400. That is our objective function. That's all we've done so far. Our first constraint is maximum gold available. Our second constraint, max platinum available. And our third constraint is demand for bracelets. So we come over here. We see now all are less than or equal to because we've chosen a maximization. This is the standard format. It also works for this question. We don't have to change any. So now we enter our constraints. The first one is the maximum amount of gold that we have available, and we know from the question we have 18 ounces. We know it is 3 ounces of gold for a necklace and 2 for a bracelet. We also have 20 ounces of platinum available. Our maximum platinum, or we have 2 for a necklace, 2 ounces of platinum for a necklace, and 4 ounces of platinum for a bracelet. Finally, our final one is down here, and that is demand for bracelets is no more than 4. Bracelets we want to signify here, so 1 less than or equal to 4. Now we've correctly entered all of our information from this question into this problem formulation, and now it's correctly been entered into QM. So we hit solve, and this is what we determine, what we have determined. We should manufacture 4 necklaces. We should manufacture 3 bracelets, and that will give us a total profit of $2,400. That is what this shows us. Problem has been successfully solved. So I'm going to save my file. We hit save, and I can close this. We'll just close it all together. So coming over to Excel, we're going to repeat this one more time. So jewelry store example. And again, the reason we're doing it in Excel, the exact same problem, is because we want to familiarize ourselves with both programs, because we will be using both in the future. Products. I guess we'll do it again. We'll make each of these columns double the size. Our product is necklaces and bracelets. Revenue, and this is because we are entering our objective function, is $300 and $400. Now we have to enter our constraints, but in this situation, resources. The first is max gold available. The next is max platinum available. And our third is very simply demand for bracelets. We come over here. We're going to go to usage, because how much of each resource are we using? These will be formulaic based, as we know. And the total available. We have 18 ounces of gold, 20 ounces of platinum, and demand is 4. We know from before that it's less than or equal to, because this is a maximization and these are limited resources. Less than or equal to, less than or equal to. Usage we cannot enter yet because we don't have our number of products produced yet. So we're going to come over here, and a necklace is 3 ounces of gold. A bracelet is 2 ounces of gold, and it must be less than or equal to 18. A necklace is 2 ounces of platinum. A bracelet is 4 ounces of platinum, and it must be less than or equal to 20. Finally, demand for bracelets must be less than or equal to 4. We've entered all of the relevant information here, so we come down here and we write down our products one more time. The first is necklaces. The second is bracelets. And we're ultimately trying to determine our profit. So once we have these squares available, now we can enter our formulas. So the amount of gold used is the amount of gold per necklace times the number of necklaces plus the amount of gold per bracelet times the number of bracelets. We repeat it here, the amount of platinum per necklace times the number of necklaces plus the amount of platinum per bracelet times the number of bracelets. And finally, the number of bracelets, or the amount of bracelets times the number of bracelets. So the last thing we have to enter is our profit formula, and profit, as always, is the price per necklace times the number of necklaces plus the price per bracelet times the number of bracelets. And all of this we successfully complete. Once we've entered all of this information in here, very simply we come up to the solver function. So we click on data. We go over to the solver function and we follow the same steps that we usually do. Our ultimate goal is determining max profit. So that's B16. It's not a minimization, it's a maximization. We're changing the cells B13 and B14. In the future, when we have more than 2 decision variables, there will be more than 2 cells here. The number of cells here is represented by the number of decision variables that we have. Right now we have 2 decision variables, so we have 2 cells that will fluctuate. We add in our constraints. The first one, the amount of gold used must be less than or equal to the amount of gold available. So D7 must be less than or equal to F7. We add that. Our next one, the amount of platinum, D8, must be less than or equal to the total amount of platinum available, F8. And we add our final one, the demand for bracelets, D9, must be less than or equal to the total demand, F9. We hit OK. We change it to simplex LP because that's what we always do. And very simply, we solve this problem. Solver found a solution. All constraints and optimality conditions are satisfied. We see here that we should produce 4 necklaces. We should produce 3 bracelets, and that will maximize our profit at $2,400, which is the exact same solution found by QM for Windows. Hopefully everybody's following along. If not, as always, you can reach out to me through Kakao, and I will attempt to explain this problem to you. Let's hit OK, and we move on. So we're going to do one more question before I leave you with the homework problem. So let's go back to our PPT now. Oh, first I should save this. Okay, and then we go back to our PPT and we move on to our next question, which is the Valley Wine Company. Again, a problem we've seen, a problem we've worked through, but one we have not yet solved with the computer yet. So that's what we're going to do now. The Valley Wine Company produces 2 kinds of wine, Valley Nectar and Valley Red. The wines are produced from 64 tons of grapes the company acquired this season. A 1,000-gallon batch of nectar requires 4 tons of grapes, and a batch of red requires 8 tons. However, production is limited by the availability of only 50 cubic yards of storage space for aging and 120 hours of processing time. A batch of each type of wine requires 5 cubic yards of storage space. The processing time for a batch of nectar is 15 hours, and the processing time for a batch of red is 8 hours. Demand for each type of wine is limited to 7 batches. The profit for a batch of nectar is $9,000, and the profit for a batch of red is $12,000. The company wants to determine the number of 1,000-gallon batches of nectar and red to produce to maximize profit. Here we are. We have this problem that we have worked through before. So rather than solve right now through this methodology by formulating the problem with you, we're going to move on to the next step. We've solved this before. This should be a relatively easy problem for you to solve. So we're going to skip one of the steps and just move right now to our problem formulation. And we see that max z equals 9,000 x1 plus 12,000 x2. Subject to these 5 constraints. So we have in this situation not 2 constraints like we started with, not 3 that we've been working with, but instead 5 separate constraints for you to work through. This is where we are now. We're in a situation where we're getting progressively harder constraints, but following the methodology that we've examined, we should have not too many problems in formulating problems of this nature as we move forward. So let's begin with QM. We're going to click Module, Linear Programming, File, New. So we're going to call this the Valley Wine example. Please don't pay any attention to the information in the back. Those are just some additional analyses that we can use with linear programming, like graphing, that it was nice enough to do for us there. But for right now, it doesn't matter. So let's call this a Valley Wine example. We know that we have two variables again, Valley Red and Valley Nectar, but in this situation we have not one, not two, not three, but 5 constraints. And we're trying to maximize our profit. So everything has been the same as what we've done, but until now, all we have to do is change the number of constraints to 5 instead of 3. We click OK, and we move to the next page. I'm going to make these a little bigger. There's no reason why other than readability. So the first one is Valley Nectar. The second, Valley Red. And we're trying to maximize if Valley Nectar produces $9,000 in profit and Valley Red produces $12,000 in profit. Then, after we successfully entered our objective function, we come over here to constraint number 1 and we enter our title, which is max grapes available. Our second constraint, max storage available. And our third constraint, max aging space available. Our two final constraints are max demand nectar and max demand red. From the natural language question, if you were able to correctly follow everything we've done so far, if you were able to formulate the problem correctly, arriving at this point should be relatively easy for you. It should be a relatively straightforward process that allows us to find the problems that we need. So now we enter all of our relevant information. Again, everything will be less than or equal to because there are no overly complicated constraints in this problem. It's a maximization. Usually we have limited resources with a maximization. So usually it is less than or equal to with a maximization. As I said, in this question, we have no complications thrown at us, so everything remains less than or equal to. Grapes, we have 64 tons. Storage space, we have 50 cubic meters. And time, oh, this is aging time available, not space, aging time. And time, we have 120 hours. We also know that we have 7 demanded for red and 7 demanded for nectar only. So we've entered that information. We just have to go now into it and enter our relevant constraints. We know Valley Nectar is 4 out of 64 tons and Valley Red is 8 per unit. Storage space, each of them are 5 per type of wine. And for aging time, it's 15 units for nectar and 8 units for red. Maximum demand for nectar is 7. So we go to nectar and we change it to 1. Maximum demand for red is 7. So we go to red and we change it to 1. Once we've entered all of this information correctly, once again, we have completed the problem. We come up here to the solve function, we click it, and we get our responses, which is 4 units of Valley Nectar should be produced, 4 batches, and 6 batches of Valley Red should be produced. If we produce that, we are maximizing our usage of our resources to generate the maximum possible profit, which is $108,000. That's what we've seen right here. So I'm going to save my file. And close QM for Windows. Then we go into Excel. We're going to open a new file. And it's the Valley wine example. Our products. And as always, I always forget right away to lengthen my columns. Our Valley Nectar and Valley Red. We are attempting to maximize profit. If we get, it's Valley Nectar. If we get $9,000 for nectar and $12,000 for red. We're going to come over here and we'll put in our resources. I'm beginning to move a little bit quicker, only because this should be getting a little more clear at this point. If it's not, you can watch again at a little slower pace or contact me if you have issues. So our resources are max grapes, max storage, max aging, max demand nectar, max demand red. So we come over here. This we'll leave blank for right now. Our resource usage and the resources available. So we're going to come over here. For grapes, we have 64 tons available. For storage space, we have 50 square meters available. For aging, we have 120 hours. Demand for nectar is 7. Demand for red is 7. This is all very basic information that should be readily available if you correctly formatted your problem. So we come over here to less than or equal to, and we can very simply fill that down using Excel's functionality. Now, usage we can't enter yet, our formula, because we haven't entered the information below, but we can enter our relevant information here. Valley Nectar uses 4 tons of grapes. Valley Red uses 8 tons of grapes. Valley Nectar uses 5 units of storage space. Valley Red uses 5 units of storage space. Valley Red is 15 hours of aging. Valley Red is 8 hours of aging. We know nectar is 1, red is 1. Now, the last thing we have to do is one more time enter our decision variables, because this is where the computer needs to run variations. Valley Nectar, Valley Red. Equal to, no, not equal. And then our total profit. And that we will enter here. So we come up here, and once all of our relevant information has been added, as we can see here, then very simply we will come in and we'll add our relevant formulas. So equal to the amount of grapes per nectar times the total amount of nectar plus the amount of grapes per red times the total amount of red. We do it again. Equal the amount of storage space per nectar times the number of nectar plus the amount of storage space per red times the number of red. The aging time per nectar times the total number of nectar plus the aging time per red times the total number of red. Here it's much easier. The max demand for nectar times max demand per nectar times, the max demand per nectar times the total amount of nectar. Max demand for red times total number of red. Oh. And the last thing we have to do is enter our profit formula, which is the profit per nectar times total nectar plus profit per red times total red. Done. We've now successfully completed everything we're looking for. We have all of the relevant information everywhere we need it. We have all of the relevant formulas everywhere we need it. So we come up here to data and we enter our solver add-on. First thing, as always, where is our total profit? Right here, B18. We're trying to maximize by changing the variable cells B15 and B16. We add in our constraints. The first one, total grapes used must be less than or equal to available grapes. Total storage space used must be less than or equal to total available. Total aging time must be less than or equal to total available. The amount of nectar produced must be less than or equal to the amount of nectar demanded. And the last one, the amount of red must be less than or equal to that demanded. We hit OK, and we have all of our constraints successfully added. We come down here to simplex LP, and very quickly we hit solve. When I hit solve, as before, my other worksheet will pop up, but I will pull this one up and we'll be able to look at the correct solution. Solver found a solution. All constraints and optimality conditions are satisfied. We hit OK. And we see that the answer is identical. Valley Nectar is 4 units produced. Valley Red is 6 units produced, which gives us a total profit of $108,000. That is our optimum solution in this situation. So once again, we've solved everything with both programs, Microsoft Excel and QM for Windows. Hopefully you followed along, because now I'm going to leave you with a homework problem. At the 40-minute mark, I will again address the class. So please, here is the problem for you. Let me save this first. And I'll leave you with this final problem. So here is your final problem. It will be relevant to your attendance quiz, so please complete it and answer the attendance quiz before the end of class. I will address us everybody at the 40-minute mark. I will see you soon. Good luck with this problem. All right, everyone. We'll continue in our next session. So hopefully, if you have any questions, please feel free to contact me. And please complete the attendance quiz before the end of class. Thank you again.